Today we will dive into an incredible scale. We will walk through 10 of the most gigantic bridges ever built in China. These are not just roads over water or land. These are colossal engineering structures that literally connect entire regions and show how extreme technologies are capable of redrawing the map of the country. Here, every line is a challenge to nature. Every kilometer is a fight against wind, water, and distance. And all of these are real projects that are already working. We begin the countdown, and now we are approaching a structure that impresses no longer just by its dimensions, but by its very shape. The Chaotianmen Bridge is a grandiose arch bridge across the Yangtze, built near the historical Chaotianmen district, where the waters of the Yangtze and the Jialing River converge. Completed in 2009, it immediately went down in history because, at the time of opening, it possessed the longest arch span in the world. The length of its main arch span is 552 meters, and for steel arch bridges, this was an absolute record. The total length of the structure is about 1.7 kilometers. Unlike cable-stayed or suspension structures, here all the power is concentrated in a huge steel arch, which takes on the load and transfers it to the bases on both sides of the span. Such a type of structure was chosen not by chance. It allowed for intense traffic while maintaining a relatively low profile over the river. The bridge is designed for several types of transport at once. Automobile traffic and urban rail transport lines pass over it. And this already significantly complicates calculations, because railway load requires much stricter limitations on deflection and vibration than a regular automobile flow. Construction began in 2004 and demanded a truly filigree assembly of giant steel elements. The arch was erected using the cantilever method. Sections were built towards each other from both banks until they closed in the center. At this stage, even the slightest mistake in geometry or stress distribution could have jeopardized the entire structure. That is why every step here required almost jewelry-like precision. Externally, the Chaotianmen Bridge looks especially expressive. Unlike bridges where thin cables or stays do the main work, here the strength of the structure is read immediately. A huge steel arch rises above the roadway and forms a highly recognizable silhouette. From the riverbanks, it literally dominates the city panorama, emphasizing both the scale of the crossing itself and the strength of the engineering idea embedded in its foundation. From a technical point of view, engineers had to conduct a most serious analysis of stress distribution, fatigue, strength of the metal, and thermal deformations. Steel, as is known, noticeably expands and contracts with temperature changes, and for an arch scheme, such movements are especially critical. Therefore, the structure had to compensate for these processes without the appearance of excessive stresses and without loss of stability. From a transportation point of view, the bridge plays a colossal role. It connects important districts on both sides of the Yangtze and simultaneously serves both everyday urban trips and a wider regional flow. From the moment of opening, it became not just a part of the street and road network, but a true symbol of the rapid development of Chongqing and its engineering ambitions. In the professional community, this bridge is still frequently mentioned as a benchmark of long-span arch design. It stands out not by the largest total length, but by the fact that it pushed the boundaries of what is possible exactly for the arch scheme. And in this lies its special value. It proved that a bridge can be not only huge, but also structurally bold. And right here, the scale goes to a completely different level. The Kong-Zhuhai-Macau Bridge is no longer just a bridge, but one of the most ambitious infrastructure complexes in the world, which literally rewires the map of the region. It stretches across the Pearl River Delta, connecting Hong Kong, Zhuhai, in Guangdong Province, and Macau, creating a direct link between the eastern and western parts of one of the most economically powerful regions in China. The total length of the system is about 55 kilometers, but it is important to understand this is not a single bridge, but a complex combination of bridges, artificial islands, and an underwater tunnel, combined into one continuous transport line. Such a solution was dictated not by a desire to complicate the project, but by necessity. The Pearl River Delta is one of the busiest maritime zones in the world. where large container ships and military vessels pass daily. A regular bridge would simply block navigation, so part of the route goes underwater into a tunnel, allowing vessels to freely pass along their routes. Officially, construction began in 2009, after many years of design and environmental research. And here another unique difficulty arose. The project united several jurisdictions at once: mainland China, Hong Kong, and Macau, each of which has its own laws, building codes, and standards. Coordinating such a project required the creation of special joint management bodies and engineering teams that were able to synchronize all processes. The main part of the bridge includes several cable-stayed spans, supported by massive concrete and steel towers. These spans smoothly transition into an underwater tunnel about 6.5 kilometers long. Its construction is a separate story. Giant concrete sections weighing tens of thousands of tons were used. They were manufactured in advance, delivered by water, carefully lowered onto the prepared bottom, and then hermetically connected to each other right underwater. Engineering requirements for this complex were extremely strict. The structure must withstand typhoons, powerful currents, intense transport loads, and even seismic activity. The designed service life exceeds 120 years, so high-strength concrete, corrosion-resistant steel, and multi-layer protective coatings were used in the project. The opening took place in 2018, after almost a decade of construction, and the result turned out to be truly impressive. Travel time between Hong Kong and Zhuhai was reduced from approximately 3 hours to 45 minutes. This is not just convenience, but a serious step towards the economic integration of the entire region, including such megacities as Shenzhen, Guangzhou, and Foshan. From a visual point of view, this project amazes not by height, but by its length and precision. The long spans extend into the horizon, and the artificial islands and tunnel entrances look like perfectly calibrated geometric shapes, as if inserted into the sea. From the air, all this resembles not a bridge, but a huge engineering system integrated into the natural landscape. Even the organization of traffic creates an additional complexity. Different traffic rules apply in Hong Kong and mainland China, so special transition zones and dedicated lanes are implemented on the bridge, allowing for a safe change of the driving system. This is another layer of engineering logistics that is rarely seen from the outside, but is critically important for the operation of the entire system. And despite all the difficulties, this project became a benchmark. The Kong-Zhuhai-Macau Bridge today is considered one of the most technically complex and massive bridge complexes in the world, demonstrating how different territories, systems, and technologies can be united into a single, perfectly functioning infrastructure. And right now, we are moving on to those structures that are no longer just huge. They begin to look truly impressive. The Sutong Yangtze River Bridge is one of the most iconic projects in China, which immediately after its opening attracted the attention of the whole world. It connects the cities of Suzhou and Nantong in Jiangsu province, stretching across one of the widest and busiest rivers on the planet. The total length of the bridge is about 8.2 kilometers, but its main feature is a central span over 1,000 meters long. At the time of completion of construction in 2008, it was the longest cable-stayed span in the world, a record that stood for several years. Even today, it remains one of the largest in its class. The Yangtze in this place is not just a river. It is a powerful water flow with intense shipping, complex currents, and soft bottom sediments. Therefore, the requirements for the bridge were extremely strict. It had to provide sufficient height for the passage of large vessels and at the same time withstand serious natural loads. Construction began in 2003 after lengthy research. Engineers had to take into account strong currents, unstable soil, frequent fogs, and even seismic factors. The bridge towers rise to a height of about 306 meters. At the time of construction, these were some of the tallest bridge pylons in the world. Special attention was paid to wind loads. In the Yangtze Valley, strong crosswinds frequently arise, which can cause structural oscillations. To avoid this, large-scale tests were conducted in wind tunnels, as a result of which the shape of the span and the arrangement of the cables were optimized. The foundations of the bridge go deep into the riverbed to withstand not only the weight of the structure, but also the pressure of water, wind, and possible seismic impacts. Underwater work was carried out in extremely difficult conditions and required high precision at every stage. Before the appearance of this bridge, communication between the southern and northern parts of the region depended heavily on ferries and long detour routes. With its opening, travel time was significantly reduced, and economic ties within the Yangtze Delta, one of the most developed regions in China, were noticeably strengthened. But to speak honestly, this bridge is no longer just about functionality. It is about visual impression. High pylons shoot upwards, and cable-stayed lines create almost perfect symmetry, forming a sense of lightness despite the giant scale of the structure. From a distance, the bridge looks almost weightless, although thousands of tons of steel and concrete are hidden behind this lightness. Since the moment of its opening, the bridge daily receives huge flows of traffic and is under constant monitoring. Systems track the slightest changes in the behavior of the structure, ensuring its safety for many years. This project became proof that China is capable of not only building long bridges, but also setting world records in the most complex engineering categories. And precisely such projects prepared the ground for even more ambitious solutions that we will see next. The Hangzhou Bay Bridge is one of the largest and most significant sea bridges ever built in China. And right from the first facts, it becomes clear how ambitious this project was. It crosses Hangzhou Bay in Zhejiang province, connecting the cities of Jiaxing and Ningbo, and its total length is about 36 kilometers, which at the time of the completion of construction in 2008, made it one of the longest transoceanic bridges in the world. Before the appearance of this giant, the journey between the cities turned into a tiring trip. One had to make a huge detour around the bay or rely on ferry crossings, which often depended on the weather and could be unreliable. And the conditions in this region, to put it mildly, are not forgiving. The bay is known for some of the strongest tidal currents in China. Dense fogs regularly arise here. Typhoons rage, and intense maritime traffic passes through. Construction started in 2003 and immediately became a project of national scale. Thousands of engineers and workers participated in it. To hold the structure in such difficult conditions, the bridge rests on more than 1,400 pillars deeply driven into the seabed. During the design, engineers had to take into account the famous Qiantang tidal bore, one of the most powerful in the world, which forms huge waves passing through the bay with incredible force. From a structural point of view, the bridge is a highway with 2 directions of 3 traffic lanes each, supplemented by emergency lanes. It is designed for speeds up to 100 kilometers per hour and allowed to reduce the travel time between the cities by several hours. And this in itself changes the economy of the region. In certain sections, cable-stayed spans are used, allowing large vessels to freely pass under the bridge without disrupting the operation of shipping routes. But perhaps one of the most unusual details is an artificial island located approximately in the middle of the structure. This is not just a technical element, but a full-fledged service hub. Here there are monitoring systems, service areas, emergency services, and even rest areas for drivers. A rarity for a bridge of this scale. The project was financed through a combination of state investments and private capital, which reflects China's general approach to infrastructure development in the early 2000s. At the time of construction, it was one of the most expensive bridges in the country, the cost of which amounted to billions. But the costs quickly paid off due to improved logistics and accelerated trade. From an engineering point of view, the bridge received advanced solutions, anti-corrosion coatings, high-strength concrete, and continuous monitoring systems designed for a service life of more than 100 years. Sensors are built into the structure, which track loads, vibrations, temperature, and wind force in real time, allowing for the monitoring of the condition of the structure. If you look at the bridge from a height, it looks like a smooth, almost endless line, extending into the distance across the open sea. The rows of pillars seem to dissolve into the horizon, creating the feeling as if it is not a separate structure, but a continuous connection between 2 shores in an empty maritime space. Today, the bridge daily withstands a huge flow of traffic and plays a key role in the transportation of goods between ports, industrial zones, and major cities. And despite the fact that even longer sea crossings have appeared since then, the Hangzhou Bay Bridge remains a crucial symbol of China's infrastructure leap in the early 21st century. If the previous bridge already seemed huge, the next object raises the bar even higher. The Qingdao Haiwan Bridge, also known as the Hangzhou Bay Bridge, is one of the longest sea bridges ever built by humanity. It crosses the waters of the bay in Shandong province, connecting the city of Qingdao with the Huangdao district and adjacent territories, forming a direct transport line where previously only detour routes existed. The total length of the structure is about 42 kilometers, and when it opened for traffic in 2011, it was called the longest sea bridge in the world. Before the appearance of this giant, trips across the bay turned into a long and tiring route along congested coastal roads or depended on ferry crossings, which, as in the case of Hangzhou, directly depended on weather conditions. This bridge became part of a massive program to integrate the rapidly growing Qingdao and its surroundings, turning the region into a single transport space of one of the most important port hubs in northern China. Construction began in 2007 and took a little more than 4 years, a pace that in itself already looks impressive for a project of this scale. At the peak of the work, more than 10,000 people were involved in the construction, and the erection was carried out simultaneously on several sections, which allowed to significantly speed up the process. The structure rests on more than 5,000 concrete pillars installed in the seabed. At the same time, engineers had to take into account the complex geology, variable water depth, and the need to preserve free shipping channels for the operation of the port. The bridge is a 6-lane highway designed for an intense flow of traffic. At the same time, it is not just a straight line. It includes interchanges and branches that connect different parts of the city, turning it into a full-fledged transport hub. Some sections pass over shallow water on elevated structures. Others cross deep channels where more powerful and complex structures were required. Operation in such an aggressive environment demanded special solutions. Salt water, strong winds, seasonal ice, and temperature changes could quickly destroy ordinary materials. Therefore, high-strength concrete, corrosion-resistant reinforcement, and advanced drainage systems that reduce the wear of the structure were applied here. Like many modern Chinese bridges, this object is equipped with a condition monitoring system that tracks loads and movements along the entire length in real time. Emergency stopping zones, traffic surveillance systems, and weather stations are provided along the entire length. Today, this seems to be the standard, but at the time of opening, such solutions were considered advanced. From an economic point of view, the bridge sharply reduced travel time. Some routes became more than twice as fast. This improved access to the airport, industrial zones, and ports, strengthening Qingdao's position as one of the key manufacturing centers of northern China. From a visual point of view, the bridge does not try to surprise with its shape. Its power is in its scale. It stretches in long, straight sections across the bay, and evenly spaced pillars create a rhythmic pattern extending into the horizon. From a height, it looks almost abstract, like a perfectly straight line drawn on the surface of the water. And precisely because of its length, it is impossible to completely see it from a single point. It literally goes beyond human perception. Disputes periodically arise around it about the exact length and world records, because much depends on whether access roads and interchanges are taken into account. But regardless of formal measurements, the fact remains, this is one of the most massive sea bridges ever built. Today, it lets through tens of thousands of cars daily and has become an integral part of the region's transport system, clearly demonstrating how China is capable of implementing projects of such scale in record time and changing the geography of entire cities. And right here begins the real shock from the scale. The Danyang-Kunshan Grand Bridge is not just one of the largest bridges in China, it is the longest bridge in the world by total length. It is located in Jiangsu province and is part of the Beijing-Shanghai high-speed railway line. Its length reaches approximately 164.8 kilometers, a figure that sounds almost unreal and is comparable to the distance between large cities. Unlike many famous bridges, it was not created for the sake of visual effect or architectural expressiveness. Its main task is efficiency, reliability, and stability under extreme loads. Construction began in 2006 and was completed by 2010, and already in 2011, trains began to run on it, accelerating up to 300 kilometers per hour. Speed was exactly the key factor in the design. The movement of high-speed trains requires a perfectly flat and stable surface capable of withstanding constant dynamic loads. Any deviations here are unacceptable. The decision to build such a long, elevated structure was dictated by the features of the terrain. The section between Danyang and Kunshan passes through a complex landscape. There are rivers, canals, lakes, soft soils, and densely populated agricultural territories. Raising the line above the ground turned out to be much more efficient than laying it on the surface. It reduced the number of intersections, decreased the impact on the environment, and allowed for better control of floods. The structure is held by tens of thousands of reinforced concrete pillars evenly distributed along the entire length. Each of them rests on deep foundations, adapted to various types of soil. To speed up the work, precast concrete elements were used, which were manufactured in advance and installed using specialized equipment. But one of the most serious challenges here is temperature fluctuations. Imagine a structure of such length. When the temperature changes, it can expand and contract by significant amounts. To avoid damage, engineers developed a complex system of expansion joints and support units that allow the bridge to breathe without losing its strength. In parallel, monitoring systems are installed along the entire length, tracking deformations, vibrations, and loads. Visually, this bridge does not amaze with spectacular spans or towers. Its power is in infinity. From the ground, it looks like a continuous line of identical pillars extending beyond the horizon. From the air, it is a perfectly straight route, crossing cities, fields, rivers, and roads, like a giant line drawn on a map. During construction, more than 10,000 people worked simultaneously on different sections, coordinating actions with incredible precision. Today, the bridge plays a key role in China's high-speed railway system, providing fast and stable communication between the country's largest economic regions. This project is listed in the Guinness Book of Records as the longest bridge in the world. And its uniqueness lies not in a single grandiose span, but in the very idea to create a continuous, perfectly calibrated structure, extending for a distance comparable to entire megacities. This is an example of how engineering can bet not on effect, but on absolute functionality, and at the same time, still amaze with scale. And here is another giant, which itself once held the world record. The Weihe Grand Bridge, located in Shanxi Province, crosses the Weihe River Valley near the city of Weinan and is a crucial part of the Zhengzhou-Xi'an high-speed railway line. Its total length reaches approximately 79.7 kilometers, and at the time of completion of construction, it was considered the longest bridge in the world until it was surpassed by later projects. Construction began in 2008 and was completed already by 2010, and shortly after that, train traffic was launched on the bridge. It was created specifically for high-speed railway communication, where trains accelerate up to 350 kilometers per hour. Such speeds require practically perfect track geometry. The slightest deviations here are simply unacceptable. The reasons for choosing exactly an elevated structure are again connected to geography. The Weihe River Basin is a complex territory with soft soils, agricultural lands, populated areas, and zones prone to flooding. Raising the railway line above the ground turned out to be the most rational solution. This allowed to reduce the risk of floods, decrease intervention in the environment, and preserve natural water flows and animal migration. The bridge structure is a long chain of reinforced concrete pillars on which precast box girders are placed. These elements were produced in advance under factory conditions, which allowed to achieve high precision and speed up construction. Then they were delivered to the site and installed using specialized equipment, simultaneously carrying out work on several sections. One of the key engineering tasks became the management of soil settlement. Different sections of the route pass through various types of soils, and each of them behaves in its own way. In zones with weak soil, deep pile foundations were used. In more stable places, lightweight structures. All this required detailed geological research and continuous control. An equally important factor was thermal deformation. Over a length of almost 80 kilometers, even small changes in temperature lead to significant expansion and contraction of materials. To compensate for these processes, engineers implemented complex systems of expansion joints and supporting elements, allowing the structure to adapt without losing stability and safety. From a visual point of view, the bridge does not offer a bright center of attention. Its effect is in infinity. From the ground, it looks like a continuous row of identical pillars extending into the distance through fields and infrastructure. From the air, it is an almost perfect straight line cutting through the landscape, emphasizing its length, not its shape. From an economic point of view, the bridge became a key element of China's east-west railway corridor. It significantly reduced travel time between cities, strengthened the economic ties of the central and western regions, and became part of a system through which thousands of trains pass annually, transporting millions of passengers. This project proved that ultra-long bridges can be built quickly, precisely, and reliably, setting a new standard for subsequent infrastructure mega-projects throughout the country. The next giant is the Tianjin Grand Bridge, one of the longest bridges on the planet, which passes through northern China and is part of the same Beijing-Shanghai high-speed line. Its length is about 113.7 kilometers, and this fact alone puts it into the elite of the largest engineering structures in human history. Construction started in 2008 and was completed already by 2010, after which the line was put into full operation in 2011. The bridge was initially designed for high-speed trains, capable of moving at a speed of more than 300 kilometers per hour, which means the requirements for precision, rigidity, and durability of the structure here were extremely strict. On its path, the bridge crosses everything imaginable: densely populated urban areas, agricultural lands, rivers, canals, and major transport highways. And exactly this became one of the reasons for choosing an elevated structure. By raising the railway above the ground, engineers not only ensured traffic safety, but also completely eliminated intersections with cars and pedestrians, which is critically important for high-speed lines. Structurally, the bridge is executed on a modular principle. Thousands of reinforced concrete pillars and precast box girders form a continuous line extending beyond the horizon. Such an approach allowed construction to be carried out in parallel on different sections, significantly accelerating the realization of the project. Each pillar was installed with jewelry-like precision, because even minimal deviations could affect the stability of the entire line. One of the main engineering tasks became the fight against uneven soil settlement. Different sections of the route pass through various geological conditions, and each zone requires an individual approach. Therefore, the structure is equipped with monitoring systems that allow tracking any changes and reacting to them in time. Special attention was paid to vibrations. High-speed trains create powerful dynamic loads, which in the absence of control can accumulate and amplify. To avoid this, special damping solutions are applied in the structure, as well as improved rail systems, capable of absorbing oscillations and providing the smoothest possible movement. This is important not only for the comfort of passengers, but also for the durability of the entire structure. Visually, the bridge does not strive for impressiveness. There are no towers here, no suspension spans, no architectural accents. Before us is pure engineering. From the ground, it looks like an endless corridor raised above the landscape. In cities, it passes over residential neighborhoods and industrial zones, in rural areas, over fields, without changing its shape. Today, thousands of trains pass over it daily, transporting passengers, businessmen, and tourists, directly influencing the economic integration of the northern and eastern regions of China. And although this bridge rarely makes it into tourist lists, its significance is hard to overestimate. It is not a symbol, it is a tool, perfectly tuned, precise, and continuously working. And here we approach one of the most powerful suspension bridges in this list. The Yangtze River Bridge in the Yichang area, known as the Yichang Bridge, is a strategically important crossing that is part of the G42 Shanghai-Chengdu Expressway, one of the country's key transport arteries, connecting the eastern coast with the deep regions of China. Opened for traffic in 2009, this bridge immediately attracted attention with its main span, about 1,200 meters. At the time of completion of construction, this was the longest span in China and one of the largest in the world. The total length of the structure is approximately 1.6 kilometers, but exactly the central span determines its scale and status. The choice of a suspension scheme here was obvious. The Yangtze River in this place is very wide, and intense shipping requires a minimal number of pillars in the water. Therefore, engineers relied on a classic suspension structure. Two massive towers rise above the banks. Between them, the main steel cables are stretched, and from them, vertical suspenders already descend, holding the roadway. But behind the external simplicity hides colossal complexity. The bridge is located in a mountainous area, where steep slopes and complex geology require careful preparation. Huge anchor blocks holding the tension of the cables were secured in massive rock formations. These structures must withstand giant horizontal forces arising from the tension of the cables and the load from transport. An additional challenge was the wind loads. In river valleys, air currents can be unpredictable, creating structural oscillations. To prevent dangerous effects, engineers carefully worked out the aerodynamics of the span, implementing solutions that reduce vortex oscillations and provide stability even in strong winds. The roadway is designed for intense traffic, including heavy freight transport. At the same time, the structure must maintain rigidity and minimal deflections to ensure the comfort and safety of drivers. For this, special support elements and compensation systems are used, allowing the bridge to adapt to temperature changes and possible seismic impacts. Visually, the bridge looks powerful and at the same time elegant. High towers rise above the river, and the road suspended between them forms a smooth arc that fits perfectly into the surrounding mountain landscape. Against the backdrop of steep slopes and a deep valley, the structure looks simultaneously dominating and organic. From an economic point of view, the significance of the bridge is hard to overestimate. It significantly reduced travel time, increased the reliability of transportation, and became a crucial element in the development of the Chongqing region, one of the fastest-growing megacities in China. This bridge is a clear example of how technologies that were previously used in coastal zones are successfully adapted to the complex interior territories of the country. And precisely such projects show how infrastructure penetrates ever deeper into the complex terrain of China, connecting previously hard-to-reach regions. And here it is, the finale of this list. But here awaits us not a single bridge, but something much more massive. The Dujiangyan high-speed railway bridge system is not a separate structure, but an entire network, one of the largest continuous bridge complexes ever created in China. It is located in Sichuan province and is part of the Chengdu-Leshan high-speed railway line. The total length of all bridge structures on this section exceeds 160 kilometers, and in essence, it is one continuous engineering organism consisting of elevated structures, river crossings, and long spans combined into a single transport system. Construction began in the late 2000s and was completed already at the beginning of the next decade, during the period of rapid development of the Chinese high-speed railway. The line was designed for trains developing a speed of up to 200 to 250 kilometers per hour, which means that the requirements for the precision, rigidity, and stability of the entire structure were maximally high. And the key decision here is the almost complete abandonment of ground sections in favor of bridges. The reason lies in the very geography of the region. Sichuan is a complex terrain with rivers, irrigation systems, soft soils, and seismic activity zones. By raising the railway above the ground, engineers not only reduced the risk of flooding, but also minimized intervention in the agriculture and infrastructure of the region. Structurally, the system is built according to an already familiar principle: reinforced concrete pillars and precast box girders, manufactured in advance and delivered to the site for assembly. Such an approach allowed work to be carried out simultaneously on a multitude of sections, accelerating construction and providing high precision of execution. But the key factor here was seismic stability. The region is prone to earthquakes, so the structure receives special isolating bearings, energy dissipation systems, and flexible connections capable of absorbing oscillations and protecting the bridges from destructive loads. These solutions became the result of many years of research and experience from previous projects. Visually, This system amazes not by shape, but by scale. From the ground, individual spans may seem ordinary, but once you rise into the air, a picture unfolds before you where railway lines stretch for tens and tens of kilometers, forming continuous, perfectly calibrated lines crossing fields, rivers, and cities. This is no longer a bridge. It is an infrastructure continent. From a practical point of view, the system connects Chengdu, one of the largest cities in western China, with key destinations in the southern part of the province. It ensures the daily movement of trains, supports tourism, accelerates transportation, and strengthens the economic integration of the region. And the main outcome here is not in the record of a single span or the height of the structure. The main result is the idea itself, the ability to build a single, continuous transport system consisting of hundreds of kilometers of bridges working as a whole. This is exactly what modern engineering looks like at the limit of its capabilities. And so, when you look at all this, it becomes clear we are no longer just talking about bridges. This is about the scale of thinking, about a country that literally throws roads across seas, rivers, and entire regions, shortening distances that previously seemed insurmountable. But now a question for you. Which of these bridges impressed you the most? The one that extends beyond the horizon for hundreds of kilometers? Or the one that is held on a single giant arch? Write the word bridge in the comments if you watch to the end. It will be interesting to find out how many of us there are. And if you like such massive stories about mega projects, technologies, and true engineering wonders, definitely subscribe. Further on, it will only get more powerful.